Hello everybody! In 1963, a Tanzanian student named Erasto Mpemba noticed something peculiar. While making ice cream, he found that his hot ice cream mixture froze faster than his classmates' colder mixtures. This observation, which seemed to contradict common sense, sparked a scientific mystery known as the Mpemba Effect. Why would hot water freeze faster than cold water? This question has puzzled scientists for decades. One possible explanation lies in the process of evaporation. When you heat water, some of it evaporates into the air. This means that the total mass of the water decreases. With less water to freeze, the process might happen faster, even if the remaining water starts at a higher temperature. Imagine two pots on a stove, one with a liter of water and the other with half a liter. The pot with less water will boil faster, even if it started colder. Evaporation also cools the remaining water, which can further speed up the freezing process. So, evaporation not only reduces the amount of water but also helps it cool down faster. Another factor to consider is convection. Hot water, being less dense, rises to the top while colder water sinks. This creates circular currents within the container, distributing heat more effectively. This efficient heat transfer could potentially lead to faster cooling and freezing, even though the initial temperature is higher. Think of a lava lamp. The heat from the bulb causes the wax to rise and fall, creating mesmerizing patterns. Similarly, the movement in water can speed up the freezing process. Section 4. Supercooling, a chilly shortcut. Supercooling might also play a role in the Mpemba effect. Under certain conditions, water can remain liquid even below its freezing point. However, this state is unstable, and any slight disturbance can trigger rapid freezing. It's possible that hot water, due to factors like dissolved gases or convection, is less likely to supercool than cold water, leading to faster freezing when the conditions are right. Imagine a tray of perfectly still water placed in a freezer. This water might supercool and remain liquid until it is disturbed, at which point it will freeze rapidly. Conclusion. While the Mpemba effect is a fascinating phenomenon, there isn't a single universally accepted explanation for why it occurs. Scientists are still actively researching the various factors that contribute to this counterintuitive observation. Factors like evaporation, convection, and supercooling likely all play a part, and their interplay might vary depending on the specific conditions of the experiment. The Mpemba effect serves as a reminder that even seemingly simple phenomena can hold complex scientific mysteries waiting to be unraveled. Thanks for watching and see you on the next video.